Okay, now are you ready?
Yeah!
Okay. It's funny because sometimes students don't know that they can be loud. You spend your entire life being told to be quiet, and then now for our first time teachers telling you to be loud. So you'll have another chance. Today we're going to be talking about a statistics topic that is regression. Okay, we'll explain what that is in a second. This is the first time we're filming together. Give yourselves a hand for that. I really look forward to doing this. We've been developing a little bit of a history now, and now we're going to make history. Okay, so with that, I want to ask you a question. Yay, math! Yay, math! Yeah, he's ready.
I was reading.
Yeah, he's ready. Primed. Okay. It is yay. Remember that it also works sarcastically. Yay! Math! Some people do that. It's okay. All right, so let's talk about it. Last time, we talked about correlation, right? Correlation basically is finding a relationship between two sets of data. Do you recall the election data that we did? Say yes.
Yes.
Okay. Nodding is fine, normally. Nodding is fine. Silent. So yeah, we have election data. So we talked about whether these students, let's just jump right into the data itself that's provided to you. These students rated their own political affiliation from 1 to 10, where 1 is very liberal and 10 is very conservative. No judgment on any of those students. Then each of those students rated their parents from 1 to 10 as they saw that one parent. Okay, that's data we've done before. And then we asked ourselves whether there is a relationship between them. As a quick warm-up, would you like to do that together and see whether there's a relationship? I see the calculators. I see it. I'm hearing them. So let's go ahead and type in this data into L1, and this data into L2, and we will see whether a relationship exists together. All right, so I can put out of here. Hear this. So in case you don't remember, the way to get to the table is stat, and then edit. Are you feeling more comfortable with the calculator in this first semester?
Yeah.
A lot of people are. A lot of people are. We could actually do a survey of how comfortable you feel with the calculator. Like before and after. That would be kind of cool. I took the time to go ahead and type those in. Move this out of the way. I'm counting 12 data points. There they are. I hear keys snapping away. That's great. So I'm going to get out of this. Once you type in student data into L1, parent data into L2, let's quit. And remind me how to calculate correlation? Stat. Good job. Calc.
4.
Option 4. There it is. And we see. Scroll down. You'd be surprised how many times people talk to themselves when they're doing computer work. Another thing I can't get over is how many times people hit clear on your calculator. Have you ever noticed that?
Yep.
We're like, okay, let me start over. Clear, 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 clear. Until it happened like 10 times. So one's enough. So here we have the correlation coefficient R, 0.5978. Someone tell me what to do with this number. What do we do with this number? You recall? I'm asking whether or not a relationship exists between student political affiliation and parents.
You look at the chart.
You look at the chart, right? You look at the chart. Those are called critical values. Here they are. Critical values for n data items. How many data items are we dealing with right now?
12.
Oh, very good. Circling. And ours was R equals 0.597 or so. For a confidence level of what? Say it together. 95%. I know this is all stuff you've done, so we're going to get to new stuff in a second. Great job. Is the data related? Yes. The data is related. There is a relationship. Is the data related with 99% confidence?
No.
No. I see nods of no. Correct. So here's what we're going to do today. Now that you know that there is a relationship, we ask ourselves, can we create a model to predict future behavior? Can we create a model to predict future behavior? This is actual data. This student is highly conservative, and that person's parent is roughly in the middle, center. This person is in the center, and then slightly conservative parents. This is a liberal student and parent, right? What if I said, what's the best prediction for parents' political affiliation if I gave you a 3 for student? Do you understand the problem? You understand the dilemma? Okay. So that's why we need to do what we're doing. And that prediction model is called a regression line. Here we go. So here we have this. First, is it significant? Yes, R equals 0.597. Hopefully you put that down. Let's plot the data, and we'll plot that in a second. Volunteer to read this? Go for it, please, yeah.
New term, the regression equation, aka regression line, aka line of best fit, is the most fitting equation of a line to capture the data. Keep in mind, this only works well if the data is correlated.
Right. So this wouldn't really be applicable if the data was all over the place. Let's go ahead and look at the data together. Let's look at the data. Any questions so far? Okay, I guess in good shape. So here I plotted it here as a reminder. You go to second stat plot. Turn your first plot on if it's not already that way. And hit enter. Notice we want to include L1 and L2. Very important. So the way to do that is to go to this, the points, the XY points. I'm feeling red today. There you go. And then zoom stat. So there's our, so do we see that there's a general relationship? We see that. Now what we want to do is we want to get whatever, we want the equation of that line. That's what we want to do today. And that's what we will do today. Yes, question? No? Okay. Pen flick. Okay, so let's get the equation of this line. The equation of a line is what form, algebra friends? Go ahead, everyone. Y equals mx plus b. School works. Very nice. Y equals mx plus b. Let's prove it. Back. My handy dandy. Okay. Y equals mx plus b. And here we are. There it is. Y equals mx plus b. So we need the slope and the y-intercept. Here's the equation for the slope. Here's the equation for the slope. Any questions? I try to make it super straightforward. Super straightforward. You know, in fact, the books, they do it in different ways. They call m something else, you know, but I just used mx plus b. Makes it simple. Standard deviation of the first group, standard deviation of the second group, there they are, times the correlation r, and then b is this data here. Now look, do you know how to get the calculator to do this? Anyone remind us how to get the calculator to get r? Well, we got r. How do we get standard deviation for y? How do we get standard deviation for x? Recall how to do it, anyone? Okay, so we got to the first place where you don't know something today. That's good. That's progress. Yeah. Yeah, I don't know something. How do you get the standard deviation? Yeah, sarcastically. Thank you. How do you get the standard deviation?
On the calculator?
Yes, on the calculator. Yes.
Stat.
Yes.
Calc.
Yes.
And then one variable stat.
Stat calc, one variable statistics. Very good. Let's do it. So fortunately, our data is all set to go in our tables. Stat, calc. Now check it out. Can I do this?
Whoa.
It'll give us both. Right on. Enter. L1, L2, yes. And voila. Check it out. It's even named. It's named appropriately. This is the standard deviation for the student group. Right there. This is the standard deviation for the parent group. Right there. Cool. And then we need our R, which we already have. Okay. So, raise your hand if you're getting more comfortable with the calculator, generally speaking. Okay, I'm going to give you more functionality. Here it goes. Rather than Instinctively, did anyone think like, oh, I better write that down? I better write that. Did anyone write that down on their paper? Or at least, yeah, starting to, yes. I'm doing that. I totally get that. I'll be like, oh, okay, so that would be 2.1514 over, what was the first one?
2.50.
2.50 something something. Fortunately for us, these are saved in the calculator, so we can use them. I see smiles. I'm very excited by that. You don't have to write it down. Avoid writing at all costs.
Oh, that's so sweet.
It is.
Oh, I was talking about something different.
Oh, too bad. All right. So let's go ahead and do it. I'm going to get R one more time for good measure. Stat calc.
The actual formula.
4.
So like,
yeah, I did give you the formula. So I'm going to get R there. So there's R. Here's how it goes. All you do is what the notes tell you to do. R times standard deviation Y over standard deviation X. Let's show you how to do it. And your hands will be raised even higher. The way to get any variable on the calculator is theirs.
I really wish I knew this last year.
Yeah, I wish I could teach it to you last year. Honest to goodness. Which types of variables do you think we're going to use? Wow. I'm going to push 5 for saving some time, even though I'm taking that time by talking right now. I could have been like pop, pop, pop silently.
Wait, what are you trying to find?
I'm trying to do, thank you for asking, I want to do this using the calculator only, okay? So using the variables stored in the calculator. Interestingly enough, once you do your calculations, R is now stored. Where is R? Where is R? Where is R? Oh, it's under EQ, good job. My emotional quotient, yeah. The next one you can do, where is standard deviation? Where is XY? So you'll do it with me. There's R times what? Of Y. Let's say it together. Where is SY? Where is SY? Where is SY? Hey Bears, where is SY? Scroll to 5. Where is SY? I'm way too excited. I screwed it up!
Damn it.
We have those days. Everybody knows what we're talking about. Everybody gets that.
6. Thank you. There's, and then statistics. There it is. Divided by SX. There's 5. 3. Close. Boom. Ta-da. Slope done. Slope done. 0.513.
It says error.
Okay, if it says error, you'll have to go and recalculate your R. Try to recalculate your correlation again. And if necessary, do 2 variable statistics again as well. Okay, 0.5139. Putting it down, 0.5139. Now we're going to go ahead and get the y-intercept with your lesson. Back here, we need the average of y's minus slope times the average of x. Okay? Let's do it. Where is y bar? Where is y bar? Where is y bar? 5. Yay. Yes, question please.
Wait, never mind.
That's why I chanted. That's the most important question. How do you get there? Variables button, theirs, and then statistics, bravo.
I found it all.
Yeah, you did. 5. I'm hitting 5. Boom. Check it out. Minus, what does it want us to do? Slope times x bar. Is that right?
Yeah.
Isn't slope saved?
Yeah.
What? How can I use that?
Bars.
Answer key. Answer key. I don't think the slope was saved. I don't think the slope was saved. So I'm going to use that.
Where's y again?
Where is y bar? Where is? It's the right question.
Oh, it's very second.
Variables. I'm going to go second answer first, and I'll show you where it is. So here, that's the slope times x bar. Where is x bar? I gotta stop. Enough. Here.
So it'd be minus 0.5139.
Yes, is that the formula? Yes, there it is. That's the mean of the second group minus the slope, which we calculated here, times the mean of the first group. Question?
How did
Yes.
you get?
Start. Yeah, I saw the hand, and then we'll come back. Yes, please.
I'm a bit confused about
Okay.
how to get how the answer just came up like that.
Oh, good job. Who can help him? How do you get the answer key?
Help me.
Second minus.
Second minus. Yeah, the negative key down here at the very bottom. Second negative.
Ah,
And the calculator constantly stores the most recent answer under that key. Okay? Question in the front, please.
That was my question.
Wow. Okay, I'm gonna hit it. Bam. There it is. 2.971. 2.971.
oh, second negative above.
This is it. That's it. We just calculated the regression line, the line of best fit. So if this is the slope and this is the y-intercept, what would the equation be, friends? I'll take a hand. This is slope, and we have thanks, error 5. If this is the slope and this is the y-intercept, what's the equation of the line? That's all I'm asking. Go ahead, step 6. Y? Do you not know? Or does everyone know and they're just saying it's too easy, I'm not saying it? Y equals
0.5139
0.5139x
plus 2.9.
plus 2.971. Very good.
Can you go back to the top?
Sure. Let me write this down. 0.5139x plus positive 2.971. That is the regression line, the line of best fit. And if you'd like to get ahead, I'm going to do it in a second after this question. Please graph this on the calculator. Awesome. Under y equals. But I'll do it with you in a minute. Okay, question. Yes, calculator. We need to see it. All right, let's graph it. Let's graph it. The way to graph is y equals. You'll notice that the plot is still on. It's fine. You want your plot on, and you want the line. All right. 0.5139. Does it look good?
Yeah.
That's awesome. X plus, what was it? 2.971. And yeah, blue is good, so it pops a bit on the graph. Nice.
Wait, what do you put for y? Wait, can you?
The equation of the line. I'll go back. The equation of the line. Slope x.
How do you get x?
Very good. This question here under, or this button here under mode. Legit.
I just press it.
Press it, yeah. It'll just come up. Yeah. Or you can look at it and hope.
And then once it's in, what do you do?
Once it's in, you celebrate. You know, there's a party going on right here, celebration to last throughout the years regarding this
What
line.
if it doesn't look right?
Did you do Zoom 9? Yeah, we can't do it too hard because then we have to do copyright infringement. I get sued, and I don't want to do that again.
Again?
That was the joke. Good job.
Do Zoom.
You hit graph? Oh no, Zoom. Yeah, that's it. Zoom 9. Try that. Okay, now that we have our best fit line, can we predict for certain student paired groups, such as? What do you want to predict? Look, so if a student has a 1, what do you think their parent will be? That's what this will do. Shall we? Let's do it. So, let's do it the rookie way. The rookie way would be 0.5139, yeah, times 1 plus 2.971. See what I'm doing? I'm plugging in x as 1, and that'll give us y. So it turns out, okay, that if a student is a very liberal cat, that his or her parent is roughly a 3. Now, Did the survey say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or did it allow for decimals?
Decimals.
It did allow for decimals. What kind of decimals? 0.5?
Large decimals.
I didn't see that in the survey, honestly. I wanna.
Whole numbers.
It looked like whole numbers.
Oh.
It looked like this. This is like you're walking up and you're just circling something, right? So if that's the case, what is this parent's affiliation?
3.
3.
So can we just look at this?
Look at what? You mean the data itself?
Yeah.
So look, the data, that's the right question. Look, the data, turns out that 1 and 3 are related. It turns out. It's coincidence. It's a coincidence. This line will give us a prediction. 1 and 3. So, why did I go over here? Okay. So there's 1 and 3. I'm going to conclude on something that's going to sort of make you hate me
Wait.
in a good way. Yes, please.
Oh, you said that plugging it in was
No.
the rookie way.
Yes.
What's the professional way?
Thank you for reminding. Professional way is, do you realize that it's already in here?
Yeah.
Is that there? So check it out. Second table. Oh, wait. Second table's auto. And let's start the table at 0. Second table. Why? Second table set.
Where's just straight up?
It shows.
Did it show for you?
Why don't you start it at 1?
Sorry, 1. Oh, 1. Okay. Does that work now?
Yeah.
So second table.
Wait, will you go back to the plot?
There. All your predictions right there. Front and center. Go back to the table set thing.
Yeah,
Sure. So second table set.
from the plot.
Oh, from the plot. So the plot, this is the graph, right? There's the graph. Y equals contains this blue equation. And so now, if that equation's in there, you can go to second table. Try that. And then you'll see all your data in there. Are you ready for super advanced non-rookie way? The thing that you know what's coming, right? I heard you say it. What's about to happen?
I have no clue.
You don't know?
Yeah.
What's about to happen? What am I going to give you? The thing that will
Oh, the
sort of
way to do
make...
the whole thing.
Yeah.
Yeah.
Interestingly, it's been right in front of us the whole time. Observe.
What?
Yeah.
What?
I know. It's really good news. So you go to stat, calc, linear regression. Oh, that's what it stood for the whole time. Or, I wonder what the slope is. Where can my slope be?
Oh my god.
Are you kidding?
Look. In all seriousness, first of all, I'm happy for you. Secondly, it's important to understand the root derivation of things, know how they came to be, then leverage your use of technology and enjoy your life. Okay, I wouldn't change this for the world. Do you have enough information now? Please, yeah.
In all the years you've been teaching this class, has anybody ever noticed the slope has been there before you taught the class?
No. Then again,
Good questions.
This class is very new at this school, so I have not done it many times. If I had done it for 10 years, it'd be cool. Which is kind of fun because if you just create it from the ground up, you don't have to like only do the formulas. Just right here.
You are the
Bam.
pioneer.
We are.
We are the pioneers.
That was a fun accent too. We are the pioneers. Yes, please.
So basically we have it all because we have A and B.
A in this case is the slope. I thought that question would come. A in this case is the slope. B is the y-intercept, as you see here. See that slope, y-intercept? Do you see that? So the question is, do we need to do it with the formula?
Nope.
What would you do if you were me?
Nope.
Is that what you want, or is that what you would do if you were me?
Both.
Agreed. Okay. Yeah. This is fine. I wish. Like. Okay, with that. Good job. That wasn't so bad, right? All right?
Yeah.
Okay, give yourselves a hand, say goodbye. Oh, that's the cue for someone to get up and turn off. Let's do it again. Bye! Awkward endings. Let's go. Ready, go.